Hey everybody. This video we're going to cover another specific type of sequences and series, and this time we're going to focus on geometric. Again, you saw this in Algebra 1, so it might look a little bit familiar. Now, a geometric sequence is a sequence that has not a common difference like we did with arithmetic, but a common ratio between any two terms, and it has to be constant, okay? So that means that essentially we are multiplying by the same value to get from one term to the next each time. Or another way you can think about it is you can take a term and divide it by its previous term to find that ratio. So for example, okay, this first one, you can see that we're multiplying by 2, multiplying by 2, and again multiplying by 2. So there is a constant ratio here. We are multiplying by 2 each time. Okay, or like I said, you can always take a term and divide it by its previous, right? So here, 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24, 2. So we have a constant ratio. So if you do have that constant ratio, then we can say, yeah, it's going to be geometric, and R is going to be 2. Now for the second one here, you can see 8 divided by 4, okay, that would give us a ratio of 2, but 20 divided by 8 is not going to be 2. It's going to be something different. So we can just stop there and say, no, this is not going to be geometric. There is not a constant ratio between our terms. Now, just like with arithmetic sequences, once you identify a sequence as being geometric, we have a specific formula that we can use to find any term within that sequence. So let's look at the sequence that we have down below here, okay? And we want to find the sixth term. Well, if I want to create a formula to find it, okay, if we look at our formula above, we need to know the first term in the sequence, which we can see as 1 here. We need to know that constant ratio, which you can see is going to be 5. Right? We're multiplying by 5 each time here. And we need to know the one that we're looking for, right? So if we're looking for a 6, that means that n is going to be 6. So now we can go ahead and actually calculate this. If I want to find the sixth term, it's going to be equal to 1 times 5, and then if we're doing the n minus 1 power, we're going to get 6 minus 1, which is 5. And then this calculation will actually give us the value of the sixth term in our sequence, which in this case will be 3,125. Now, you might be thinking that seems a little big. Okay, but remember, geometric sequences, we're multiplying by some number over and over and over. Okay, if that value is greater than 1, it's going to look like exponential growth, right? It's going to grow very quickly. Now, again, if we can do a geometric sequence, a geometric series is just the sum of the terms in that particular sequence. And if we know that it's geometric, then we have a specific formula that we can use to calculate that sum very quickly. So let's go ahead and take a look at what information we need. Okay, we need to know the first term of the sequence, we need to know that constant ratio, and we need the number of terms that we're summing up. So let's look at the example below here. Okay, my first term, looking at the sum here, is 4. I am finding S14, which tells me I am looking to find the sum of the first 14 terms. So now we just need to know that ratio. Now again here, you can see we're going from 4 to 20, 20 to 100, 100 to 500. We are multiplying by 5 each time, so that constant ratio is going to be 5. So let's go ahead and calculate our sum. All right, S14 is going to be equal to 4 times 1 minus 5 to the 14th power, all divided by 1 minus 5. And you're going to have to be very careful when you type this into your calculator. Make sure you're including parentheses everywhere. I would make sure that, when you go to divide by your denominator, you're either putting this in parentheses or actually calculating that number before dividing. Okay, so just be careful with your parentheses. It's very easy to miscalculate these because we type it in wrong and then the calculator isn't really doing what we want it to do. So be very, very careful. Put in lots of parentheses. Okay, so this calculation, you know, if we actually plug it in and do it all correctly, right, that's the goal, is going to give us a massive, massive sum. Okay, if we sum up the first 14 terms in this sequence, the sum is going to be 6,103,515,624. Now again, right, we're not just finding the terms, which we know are going to be huge because it's being multiplied by 5 each time. But then on top of that, we're turning around and we're actually adding them all together. So yes, this is going to be a massive number. That's not super uncommon with geometric sequences. Now let's look at one that has summation notation. Okay, and again, remember, summation notation is just another way to show series. We still need the same information. We need the first term. We need the ratio. We need the number of terms that we are summing up. Now, the nice thing about the summation notation is you immediately know what that common ratio is, or that constant ratio. Okay, it's the base of the exponential, right? 2 to the n minus 1 power means that the ratio is 2. Okay, so that's easy. The first term, remember we just need to plug in 1 for n. So if I do 2 to the 1 minus 1 power, that's really 2 to the 0, which we know is 1. And then if we're summing up the first through the 25th term, that means it is 25. The nice thing about this is we do not need to actually know what the 25th term is like we did with arithmetic series. So here, we can calculate our sum, okay, the same way we did previously. We're just making sure that we're plugging in our values properly and typing everything in the calculator correctly. To our formula. Okay, we type it into our calculator, and we find this time that the sum is, again, very large. Not as big as last time, but still a very big number. All right, that is it for this video. Let me know if you have any questions. And remember, this is specifically for geometric sequences and series. You cannot blindly apply these formulas whenever you want. It has to be within that particular scenario. Have a wonderful rest of your day.